Okay, so again, knowing your vocabulary, knowing your theorems and postulates is extremely important to being successful in geometry, but particularly with our proofs. Because our proofs require us to recall what we know about our different definitions, what we know from our theorems and postulates to help us derive our next steps and help us to prove what it's asking about. So if this would have been a quiz, how would we have done? Yeah, we've got to make sure we know our theorems and postulates and our definitions. That's Unit 1 right there, right? That's nothing new. And as we continue throughout the year, proofs themselves, how we go about them doesn't change. What changes is how much more information we know. We're going to be using that linear pair postulate even in May. Okay, so these stay the entire year, and you must know them inside and out. You must know the differences as well. So let's recap what each of these are and when we use which one. Okay, who feels confident enough to tell me the definition of linear pairs? Go ahead, Lucy.
Two adjacent angles whose sum of their measures is 180 degrees.
I accept the first half. Ankit?
Two opposite rays whose common sides form an angle.
You're getting very close. Anyone else want to give it a try? All right, let's take some pieces of this. Spider, do you want to go ahead?
Two rays add up to 180 and form opposite.
We're getting a little too much there, Will.
Two adjacent angles whose rays are opposite.
Let's go with that. That's the closest we've gotten so far. So two adjacent angles. We've got that piece. And then let's combine that idea with the opposite rays. So two adjacent angles whose non-common sides form opposite rays. That is all that the definition tells me. It simply tells me if we have two angles next to each other and they have those opposite rays, that makes linear pairs. That is all it tells me. It does not tell me anything about supplementary. So my definition in terms of proofs simply helps us to identify that they are linear pairs. Okay, so if we are identifying them as linear pairs, maybe from the picture or from information given to us, we're identifying, saying angle 1 and angle 2 are linear pairs, that's your definition. You cannot say anything more using just the definition. Now, what about the linear pair postulate? Who feels confident to me that? Cameron?
All linear pairs are supplementary.
Perfect.
Oh.
Linear pair postulate is the one that tells me that all linear pairs are supplementary. So all linear pairs are supplementary, or just linear pairs are supplementary. Okay. So this is what allows me to make that statement about linear pairs being supplementary. But this does not allow me to say that their measures have to be 180. It only allows me to say that they are supplementary. So the definition allows me to identify them as linear pairs. Once I know they're linear pairs, then with the linear pair postulate can I say that they are supplementary. But I can't say anything more than that. What allows me to say that if they're supplementary, their measures have to be 180?
Definition of supplementary.
The definition of supplementary angles. So our definition of supplementary angles is two angles whose measures add up to be 180 degrees. Two angles whose measures. Wait for this before to come back with us. Okay, two angles whose measures add up to be 180 degrees. Now, it might be slightly different. Two angles whose sum is 180 degrees, like that. But it's the definition of supplementary angles that allows us to say if it's supplementary, then we know it adds up to be the 180. Okay, so this is what allows me to say it adds up to be 180. Okay, so this is huge, knowing the differences between here. Definition of linear pairs only lets me look at the picture and say, hey, these two angles are linear pairs. If if you want to say that they're supplementary, you've got to first state that they're linear pairs, and then you can say, since they're linear pairs, I know by the linear pair postulate they're supplementary. Then, and only after we say that, can we go ahead and write that equation, the measure of angle 1 plus the measure of angle 2 adds up to be 180. That's because we know they're supplementary. So definitional pairs only lets me identify them. Linear pair postulate only lets me say that if it's a linear pair, then it's supplementary. And definition of supplementary angles only lets me say if it's supplementary, that adds up to 180. Which means I cannot jump from my linear pair definition to my supplementary angles definition. You have to use that linear pair postulate to bridge that gap. Questions on those? You must know those. Okay. So now the other common mistake that we see is definition of vertical angles versus the vertical angles theory. Who feels confident enough with their definition? Go ahead, James.
Two lines that intersect create four congruent angles.
Okay. We can't pull from there because that could just be four right angles, right? We need something more specific. Any other thoughts with our definition of vertical angles? Go ahead, okay.
Two intersecting perpendicular lines.
Okay. They don't have to be perpendicular though, and that didn't say anything about our angles, so we want to still get something with our angles. Get a little bit closer.
Two angles that are adjacent but show same vertex anywhere.
You're very close with that. Let's build upon that. Go ahead, Sam.
Two angles that have the same vertex and are congruent.
We're getting close. All right, so definition of vertical angles. Two angles whose sides form opposite rays. Two angles whose sides form opposite rays. So again, if I have one angle drawn in, the other angle must be opposite rays. It would be opposite of this one and opposite of that. That wasn't a very good opposite. We talked about how it makes that nice X, but again, it's angles that we're talking about. They don't have to be perpendicular. They just need to have that their sides are opposite rays, meaning that it kind of shows that straight line across. So the definition, again, only allows me to look at a picture and identify them as vertical angles. Okay, so again, this only allows me to identify vertical angles. Does it say anything about their measures? Anything about congruency? Anything more at all? Does it mean nothing more than saying, hey, if you see this, they're vertical angles. Or if someone tells you angle 1 and 2 vertical angles, you can know it looks like this. Alright? But what does the vertical angle theorem tell me? Who wants to give a chat?
Two angles are vertical angles, then they're congruent.
Yes, so the vertical angle theorem is what lets me make that congruency statement. And we can go even shorter with that, just say vertical angles are congruent. But Sam, I like what you had, it was in that nice if-then format. So vertical angles theorem is what allows me to then state that they are congruent. The definition just allows me to identify, say, hey, these are vertical angles. Once I know they're vertical angles, then and only then can I use the vertical angles theorem. That only applies to vertical angles. They must be vertical angles before I consider them. Alright, so again, let's recap our differences here. Linear pairs and definition of vertical angles. Those definitions only simply let me see the picture and say, hey, that is a set of linear pairs, or that's a set of vertical angles. The linear pair postulate lets me then take it a step further. Now that we know they're linear pairs, we can say they're supplementary. Similarly is my vertical angles there. Now that I know they're vertical angles, I can say they're congruent. And then my definition of supplementary angle says, hey, if they're supplementary, their measures have to be 180 and vice versa. Now the last thing to keep in mind, this is just one that's often forgotten about, is our definition of congruent segments. And likewise our definition of congruent angles. These allow us to go from measures equal to figures congruent. or vice versa. So we know our angle addition postulate, segment addition postulate, that is based upon our measures. The measure of angle ABC plus the measure of angle CBD equals the measure of angle ABD. That's based upon our measures. If I want to switch it to say angle 1 is congruent to angle 2, I'd have to go use my definition of congruence. Okay, so don't forget these guys. These allow us to get it into the format that's necessary. Okay. Any questions on our differences with this? Huge. Very important. Okay. So now let's go ahead and dive into our first proof for today. Our first straight geometry proof. In this one, we're actually proving that theorem, the vertical angles theorem. Now, in geometry, you should never have a two-step proof. It needs to be at least 3 steps or more. If you find yourself doing a two-step proof, that means you need to be proving what you just used. For example, we just talked about the fact that the vertical angles theorem tells us vertical angles are congruent. And here they're asking us to show that the vertical angles are congruent. That's what we're proving. Now, they told us that we're proving it. But if you were to go through and say, angle 1 and angle 3 are congruent by vertical angles theorem, and you're done. No, that's what we're trying to prove. So you should not have just a two-step proof. If you had only 2 steps, that means you use the proof you use the theorem you're trying to prove. So you've got to not use it. Otherwise, you're using circular reasoning. Okay, so our given says angle 1 and 3 are vertical angles. Let's go ahead and set up our 2-column proof here, statements and reasons. Okay, statements and reasons. And I think it's best to go ahead and just list our given right away. If there's only one piece of our given, you need to list that first. If there's more than one piece, you can list the other pieces as needed. I like to state them first so that we don't forget them and then lose points for not listing them. All right, angle 1 and angle 3 are vertical angles. What's my reason for that? How did we know that to be true? They gave it to us. Otherwise, we wouldn't have done it. Oops, that is still step 1. Okay. Now, as we're doing proofs, again, look at your given statement. See, is there information we can pull from there and put on our diagram just to help us out visually? Especially as we get into more in-depth proofs, then markings on the diagram will really help you to kind of see what's supposed to happen. But if we look, it says angle 1 and 3 are vertical angles. There's really no notation for us to put onto our diagram, in addition from just seeing that angle 1 and 3 are vertical angles. There's really nothing more we can add to this. Now, we're trying to prove that 1 and 3 are congruent. And again, we cannot use the theorem. We cannot say 1 and 3 are congruent by vertical angles theorem done. Two-step proof does not work. We're trying to prove that, so we cannot use it because that's what we're proving. So let's think what else we know about our picture here. Now, they gave us a little bit of a clue because they wrote an angle 2 here, even though nothing was stated about that. So take a look at angles 1, 2, and 3. What else do we know about this picture? What else can we say about it?
Angle 1 and angle 2 are supplementary.
Yeah, we can say angle 1 and 2 are supplementary. Anything else supplementary? Good, angle 2 and 3 are supplementary. Now, how do we know that they're supplementary? Definition of supplementary angles tells me that supplementary means their measures have to be 180. But they didn't give anything about measures.
The definition of vertical angle. They're not vertical.
So the definition of linear pairs lets me say, hey, these are linear pairs. And then, now that I know they're linear pairs, what can I say? Not straight angle, I like your thought there, but not quite. So they're supplementary. And what allows me to say if it's a linear pair, then it's supplementary? Linear pair postulate. See that progression there? Good. And so since then they're supplementary, then, Jalen, we can go and say their measures have to be linear. So let's kind of think through this, because as we're doing proofs, it's good to get kind of a general game plan, brainstorm, get that big idea of what you want to do. If we can show that those add up to be 180, that's the supplementary, and these add up to be 180, does angle 2 change? We know that. So if this stays the same, we're gonna have to be that 1 and 3 have to be the same. So we can set up that equation and show that. Then we can probably get to show that 1 and 3 are the same measure, which means congruent. We're going to use that idea. Our big idea is we want to get to that point of showing that their measure is actually 180, and maybe you set them equal or something like that. So that's our big idea that we're aiming for, but we've got to build up to it. So let's go write down what we've said so far. We know that 1 and 2 are linear pairs. So we have to first identify them as linear pairs before we can say anything about the fact that the linear pairs means anything. So angle 1 and 2, make sure you use the notation angle 1, angle 2, are linear pairs. And since we're going to state the same thing with 2 and 3, same reason, we're talking about the same stuff here, let's just go and list it. Angle 2 and angle 3 are linear pairs. And what was my reason that I could state that they are linear pairs? Good. Definition, because the definition only tells me, definition of linear pairs, only tells me that I can look at that picture and say, hey, those are linear pairs. Yes?
Instead of writing it all out, can you just say vice versa?
No, you have to list it up. Alright, are we good so far? And then we talked about that since they are linear pairs, then we can say they're supplementary. Angle 1 and angle 2 are sup. I'm fine with you guys abbreviating supplementary. Vertical angles, if you want to just say capital V, capital A, I know it looks like Virginia, but I'm fine with that for vertical angles. Again, you can use that angle notation. So angle 2 and angle 3 are sup. And how did we know that linear pairs meant supplementary?
Linear pair postulate.
Good, linear pair postulate. Linear pair postulate. And you can abbreviate postulate, that's good with that. Okay. And then we talked about how because they're supplementary, now we can start talking about their measures. Alright, so now we actually get some nice equations. Because we need an equation that relates 1 and 3, right? To be able to get this to be congruent to each other, we need to show their measures equal. So we need to get them in the same equation. That's what we're working on. Alright, so linear pair postulate says that they're supplementary. And if they're supplementary, their measures, measure of angle 1 plus the measure of angle 2 equals 180. And same thing for our other statement. Measure of angle 2 plus the measure of angle 3 also equals 180. So the measures have to be 180. And what was my reason that let me say if they're sup, then that must mean they have to be 180. Definition of supplementary angles. A little bit more space. Okay. Now, guys, as you're doing your proofs, if you have that space, you could write these next to each other. That's fine. Just put a semicolon in between. I personally like to see them stacked underneath one another, but you can write the next one. Okay, so now we said we need to get 1 and 3 in the same equation. Right now I have 2 separate equations, but I need to get them in the same one. What are your guys' thoughts? What can we do that gets them to be the same equation so we can simplify it? Lucy?
Measure of angle 1 plus measure of angle 2 equals measure of angle 2.
Do you guys think we can do that? Yeah. Let's go ahead and do that. So measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 3. Why was I allowed to do that? Good, they're both equal to 180. So what property allows me to then make that statement? Substitution or transitive. So transitive works because we're taking this entire piece. Remember, it's kind of like that law of syllogism, right? 1 and 2 is 180, and 180 is 2 and 3, so 1 and 2 is 2 and 3. So we could say transitive, but we also talked about anytime you say transitive, you can do substitution, right? It's like we're taking this and substituting it in here for 180. So either transitive or substitution property. I'm going to write transitive just because it's more specific, but I would accept either one. So transitive property. Alright, so now we've got this, and this is great because now we see that 1 and 3 are sitting in the same equation, but there's more than what we want. Can we take them up?
You could do the subtraction property of equality to subtract the measure of angle 2, and then you'd be left with the measure of angle 1 equals the measure of angle 3.
Very good. We want to get rid of this pesky guy. We know since it's the same thing on each side, if we subtract it from both sides, then we're going to be left with just the measure of angle 1 and measure of angle 3. So if I go through and actually subtract that out, because that's just a number of some sort, right? We don't know what it is, but we know that it's some value, that's what measure represents. And those are going to cancel, and we're left with just measure of angle 1 equals measure of angle 3. So let's go ahead and do that. Alright, so the measure of angle 1 equals the measure of angle 3. And as Aman said, we used our subtraction. We subtracted the same thing from both sides. Alright, now are we done? No, why not? Right, it says to prove that they are congruent. We've only proved the measures are equal. If the measures are equal, are they congruent? Yeah, so we can make that statement. Angle 1 is congruent to angle 3. But why? What allows them to do that? I heard it somewhere. Was that you? Yeah. Since I have two angles are congruent, the measures are equal. If their measures are equal, their angles are congruent. So just definition of congruent equals. Definition of congruent angles. And we're doing congruent angles because we're working with angles, not segments. So again, definition of congruent angles lets you go back and forth between these two. And you must make sure that your proof statement matches the proof statement given to you. So notice that when we went through and did our proof here, we set these equal to each other, but say you not accidentally, it's okay if you would have done this. Say you would have written this piece first, measure of angle 2 plus measure of angle 3 equals angle 1 plus angle 2. Then that would have flipped your order around, so you would have had to then have an additional step of symmetric property where you flip it back. So again, it's helpful if you look at that proof statement as you're working through, you're like, hey, I want angle 1 on the left, let me make sure when I set it up that my angle 1 is on the left. Alright, questions with that? So this one ended up being 7 steps. You could have a proof be anything from 3 steps to 15 or 17 steps. Here we see that once we set up that equation, then it's really just those algebra properties, right? And also, as we talked about, say if we have linear pairs and we want to show those measures equal to 180, it does take about 3-4 steps that are going to accomplish that. So the big idea was really just get them in 180 and set it equal to each other and solve, but it took a bit to get there. Right. Any questions on this? Okay. So now let's take a look at that next proof. So now we're going to prove the congruent supplements theorem. Theorem that everyone forgets about, but is actually very helpful. So let's go ahead and set up our 2 columns. Statements and reasons. again, let's fill in that given statement. Angle 1 and angle 3 are sub. Likewise, angle 2 and angle 3 are sub. Now they gave us a picture here, just a picture of angles 3, 1, and 2. We technically didn't really need one for this. They could have just given us that information, we could have drawn our own picture. But what they tell us is that 1 and 3 are supplementary, these guys, which means what? They're supplementary. It measures out to 180. And then they tell us that also 2 and 3 are supplementary, which means what about those two? Their measures out to be 180. Did angle 3 change? So does it seem logical that 1 and 2 have to be the same? They're adding to the same amount, and 3 stays the same, 1 and 2 must be the same. Okay, so you're going to notice that this looks pretty similar to that last jump that we were just doing. So let's again, the fact that they're supplementary, there's nothing really we can add into our diagram to help us out visually. So let's just go ahead and translate. What does supplementary mean? Their measures that to be 180. Oh my goodness, I forgot my given. Alright, so again, let's translate. They tell us they're supplementary. What do we know about that? We know that means their measures, measure of angle 1 plus measure of angle 3, adds up to be 180. And measure of angle 2 plus measure of angle 3 also adds up to be 180. What's my reason for that? Good definition of supplementary. See that they're sub. Translate that to F1. Alright, I want you to try now on your own to go ahead and finish out this proof. We're trying to get, notice, angle 1 congruent to angle 2. And like I said, it's going to be similar to what we were just doing at the end there. So I want you to go ahead and try, finish out this proof and see what you do. Alright, once you get it, go and check with someone nearby. See if you guys got the same thing.
Was that a microwave out or
Alright, let's see how we did. Go ahead and bring it back up front. How many steps did we take? 5? Alright. Let's see. What did we do for step 3? Transitive. Did we go ahead and set these equal? Okay. Now again, it's good to think smarter, not harder. I see angle 1's on the left, so I'm going to put this piece on the left. Measure of angle 1 plus the measure of angle 3 equals measure of angle 2 plus measure of angle 3. Is it transitive?
Yes.
Transitive property. Alright, now what'd you guys do? Good, what do we subtract? Good, so we got rid of this guy. A little bit different from last time in its location, but still giving us the same result. And that was subtraction, Pope?
Yes.
Property and equality. Alright, and then finally, can I make my statement?
Yeah.
And what was my reason for that? Good. Definition of congruent angles, not segments, because we're dealing with angles. Alright, any questions on that? Now you'll notice the bottom of your paper says, note that the proof for congruent complements theorem is very similar. Your angles would be added up to be 90 rather than 180. And also, if we look at this side by side with what we just did, let's, hold on, give me a moment. Okay, if I look at this side by side, this piece that we did on proof 1, where we set them equal to 180 and then show that it was congruent here, all that work was basically the same thing as here, right? So if we would have recalled our congruent supplements theorem, we could have just used that here and saved ourselves that time. And we'll be using congruent supplements theorem throughout the year, and students usually forget that one, so they end up having to go through and do 3-4 extra steps to prove it within it. But if you recall that, the theorem tells us 2 angles supplementary to the same angle, these 2 angles are congruent. Likewise, if I stopped and look right here, I have 2 angles supplementary to the same angle. I could have stated that these were congruent. I could have gone from step 3 to step 7 by the congruent supplements theorem. So it's a good theorem, don't forget it. If you do, you can still get to the answer, but you're probably going to waste about 5 minutes doing so. Alright. Questions on these 2 before we see the back side? Okay. Alright, so next we're proving the right angle congruence theorem. We got all kinds of things we're proving here. Could I prove the linear pair postulate? Yeah. What is a postulate?
Theory.
A statement that can't be proven. Postulate and theorems, postulate and axioms, we said they're interchangeable, are statements that can't be proven. So linear pair postulate is actually what we cannot prove. It's one that we accept as true, we all agree that it's true, but it's so basic that it cannot be proven. here we have angle X and angle Y are right angles. Now in our diagram here, it looks like they already drew in that notation, that right angle notation. So there's nothing more we can really add to the picture. Now we're trying to prove that angle X and angle Y are congruent, which again, that's what our theorem says. So we cannot use the theorem, that's what we're trying to prove. But let's brainstorm about how we can get there. They didn't give us any other information on our diagram, but they told us that they're right angles. What do we know about right angles?
They're all equal.
They're equal, but we know that by the congruence theorem. How do we know they're equal?
They add to
If I had two right angles, that would have to be
one of
180.
them?
That's just one. Good. So the definition tells me a right angle is an angle whose measure is 90 degrees. Do you guys agree that 90 and 90 are the same? So if I have two angles that are 90, then they must have the same measure, which means they're congruent. So that's our big idea there. What do we know by right angles? We know that right angles means the measure is 90. If I know the measures are 90, then I can probably set them equal to each other once again. So let's go ahead and head down that. So angle X and angle Y are right angles. And that was given to me. Now we can expect this proof will probably be shorter, considering the fact that we don't have to deal with angle addition postulate. We don't have to deal with linear pair postulate and supplementary and all that jazz. Just simply, what does that definition mean? Okay. All right, so angle X and Y are right angles. And we said if they're right angles, that means that their measures are 90. So the measure of angle X is 90 degrees. And the measure of angle Y is 90 degrees. Make sure you have that proper notation. What was the reason why I knew that?
Definition.
Yeah, it's what a right angle is. Definition of right angle. Okay. What do you guys think we can do from here? Bonnie, did you have a question? No, complementary means two angles that add up to be 90. Here it's just one angle itself. Yeah, can we say measure of angle X equals measure of angle Y?
Yeah.
What allows me to say that? Yeah, transitive once again. Measure of angle X equals the measure of angle Y. And again, looking at our proof statement, we want the X on the left, so we went ahead and wrote it on the left. Because if X is 90 and 90 is Y, X is Y. So transitive, or again, you could say substitution. I'm going to stick with transitive. Alright, what do I need to state to take it home? Good, by congruent definition of congruent angles, I can translate measures into congruent figures. So angle X is congruent to angle Y. That's once again my definition of congruent angles. Okay, questions on that one? That one was probably the most bare basic straightforward one we had. Alright, now 4 and 5 we've got to draw in some pictures. So let's start off with 4. This is the diagram that would normally be given to you, but it did not make it to your notes. Alright, so we've got a few different angles here. So this is angle 1, 2, and 3. And then we'll label it with our letters as well. A, B, C, D, and E is my vertex. Give me a little bit to write that in. I know, we have to put something. Oh, there's a typo. Okay, catch. Alright. Do we all have the diagram drawn?
Yeah.
We got one yes. So let's go.
Yes.
All right. Now there's a typo here. This should say measure of angle AEC. Feel better now, Lucy? Yeah. Don't worry, I've got it fixed for next year. All right. So they gave us the angle 1 and 3 are congruent, or sorry, the measures equal. We know we can translate that to congruent. And then we want to prove that the measure of AEC, this big guy, is equal to the measure of BED. Now notice how our proof statement is in measures equal. So we probably won't need to switch it to congruency because we have measures and we finish in measures. Sometimes you do have to change in the middle, but it doesn't look like we'll have to. All right, let's go ahead and start off with what we know. Statements and reasons. And they gave us that the measure of angle 1 is equal to the measure of angle 3. That has been given. Alright. Now let's again talk about what we have. Let's kind of brainstorm, get the big idea of where we're going. They gave us that the measure of angle 1 is equal to the measure of angle 3. Let's go ahead and mark that on our diagram. They told us that this and this are the same. Do you agree we can make those marks there? Okay. So 1 and 3, the measures are the same, meaning that they're congruent if we need it. And then what it's asking for us to show is that AEC, this big hunkin' thing, is equal to BED, this big hunkin' thing. Now, this is what we're trying to show here. We have 1 and 2, and then 2 and 3. Does 2 stay the same?
Yes.
So if 1 and 3 are the same, and 2 stay the same, then 1 and 2 should be the same amount as 2 and 3. So it's a little bit different. Before, we're trying to show that these guys were the same. But now we know they're the same, we're trying to show that the big hunkin' thing is the same. Alright? Now what allows me to take these two together and talk about the big hunkin' thing? Angle addition postulate. So we're probably going to have to use angle addition postulate to even get an equation for AEC. In order to show my proof statement here, I need to show that whatever AEC is the same as BED. I've got to build that up. So let's start off by first saying what we know about AEC, what we know about BED. So let's just do that in step 2. The measure of angle AEC. What is AEC made up of? 1 and 2?
Yes.
Isn't it nice to have those numbers written in for us? If they weren't there, we would have to say measure of angle AEB plus the measure of angle BEC. But it's so nice to just use a measure of angle 1 plus the measure of angle 2. Do we agree with that statement? Okay. So angle addition. But we're going to have to also do this for BED. So since we're doing the same thing, let's just go ahead and list it here. So measure of angle BED. And that's made up of 2 and 3. And what was my reasoning for both of those?
Angle addition
Angle
postulate.
addition postulate. Common one in our early days of geometry. Angle addition postulate. Remember, angle addition postulate could be written if for some reason I wanted to say measure of angle 1 is equal to AEC minus angle 2. Remember, we could see it with that subtraction. We still call it angle addition postulate, it's just another form of it, but you might see that on your homework, you might see that on quizzes and tests. Just they are both angle addition postulate. Okay, now again, in order to prove that these are equal, I need to show that they are made up of the exact same thing. I cannot set them equal to each other and start to do some subtraction Because that's what I'm trying to prove. I'm trying to prove that they're equal. So we cannot set them equal and subtract angle 2 because we're trying to show that they're equal. Right? But we need these to be the exact same. Are they the exact same right now?
No.
No. What can I do to try to get them to be the same? Teresa, what do you think?
You can take those 3 words and measure angle 1 plus measure angle 2 equals measure angle 2 plus measure angle 3.
Well, got to be careful with that because that's stating, when you do that, we're assuming that these are equal. But that's what we're trying to show, right? So if I was going the other way where I knew those were equal, I'm trying to show 1 and 3 are the same, that would work. But we're kind of going opposite of that. We now know 1 and 3 are the same, so we've got to show the big ones are the same. Thoughts? Can you do?
Like maybe we can do like angle or the measure of angle AED equals measure of angle AEC plus the measure of angle EED.
That's a thought there. Now do be careful. AED, if we said AEC and BED, we have 2 twice. We would want to say this plus that guy. That's a good thought, but that's not going to be the quickest way there. Other thoughts? Cameron?
Like, since measure of angle 1 and 3 are equal, can we substitute for each other?
That sounds great to me. Yeah. Take a look. These are the same, right? Here's a hint. You're going to use your given within your proof. If you did your proof and never used your given, you might want to go back and look again. They gave this to us for a reason. Since these are equal, then I can just replace one of them, right? Now, it doesn't matter which one you replace. I'm going to just go ahead and replace this guy with 3, so then I have a 3 and 2 in each of them. You could replace, I mean, you don't want to replace them both because then you're going to have the same problem, but just reverse. So you could replace in the first one or replace in the second one. I'm just going to stick with the first one. So yeah, let's just substitute. We know that they are the same values, so we can substitute this. All right. The measure of angle AEC. Instead of using angle 1, let's use the measure of angle 3. All right, so now we have it's made up of angle 3 and angle 2. And what did we do there? We substituted. Good. Substitution. Okay, now you got to be careful here. Again, for us to show that they're equal, they have to be exactly the same. Are they currently exactly the same?
No.
No, they have the same pieces, so they're not exactly the same. They need to be exact. So how could I change this to match up with it there? Commutative property, good. So commutative property lets me take those individual pieces and flip-flop them around. So measure of angle 2 plus the measure of angle 3. So commutative lets me take individual pieces within that equation and flip-flop them. Remember, symmetric takes the entire equation and flips it. Commutative is within it. Okay, so commutative property. Okay, now, do they perfectly match?
Yes.
Woohoo! Now, again, work smarter, not harder. Which one do we want on the left?
AEC.
AEC. Alright, so the measure of angle AEC equals angle 2 and 3, which equals BED. Measure of angle BED. So what would be my reasoning for that? Substitution or transitive? Transitive is true because, again, we're taking the entire side and replacing it. Okay, I'm going to go transitive. Substitution also goes. Transitive. Okay, questions on that?
It can be substitution.
You could say substitution. If you're ever not sure, just say substitution. All right, questions on that? Yes.
For the third
Mhm. So what we did is we said since 1 and 3 are equal, I can take this here and replace it with 3. So I just took angle 1 and replaced it with that measure of angle. And I could only do that because we were told it later. Other questions on this? It's a good question. Okay. So in our last one, another diagram. Go ahead and draw those two intersecting segments. And we've got S as our intersection. And then we have R on top, segment RT, so T in the bottom. And then P on top, and segment QP. So sequence of reasons. Now our first, measure segment RS equals the measure segment SP, and the measure segment QS equals the measure segment ST. That has been given. Alright, now this is one where we can actually take some of our information and put it on our diagram here. They told us that the measure of RS is equal to the measure of SP, so we can put a 1 tick mark on each of those. And the measure of QS is equal to the measure of ST, so QS and ST. Different measures than the earlier ones, we used the 2 tick marks. So I think that helps out visually. Does it make sense then that RT made up of a 1 and a 2 is going to be the same as QP made up of a 1 and a 2? Yeah. And since we're dealing with segments here, we don't have quite as many theorems and postulates that deal with segments. We're not going to be using the right angle congruence theorem. There are no right angles. We're not even talking about angles. We're only talking about segments. So when, in terms of segments, I mean, we've got definition of midpoint. Do they give us a midpoint though? No. We've got segment bisector. Do they give us a segment bisector? No. We've got segment addition postulate. We maybe use that.
Yeah.
And honestly, I'm struggling to think of any other segment thing. Now, we might have to use definition of congruent segments, because we're doing segments, but notice again it's measures equal, finishes and measures equal, so we probably won't need that. Alright, so would you agree perhaps the big idea here would be set the entire thing made up of the pieces. This entire thing is made up of the pieces by segment addition postulate. And then again, be careful. We're trying to show that RT and QP are the same, so you need to show that whatever RT is made up of is the exact same as whatever QP is made up of. Don't set them equal, because that's what we're trying to prove. Show that they're made up of the same. Questions on that? Okay. So your homework is again worksheet 5. I do want you to also try this proof. And remember, next class we'll have a quiz over what we've learned with proofs and properties of segments. Okay, so again, your homework, worksheet 5, you just got. And I do want you to go and try this guy as well.
This is a package. Yeah.
Yeah, look, there's only 3 that fit on one, and you're only doing half of them. Get over it. Alright, you guys can go and head to lunch. Have a good day.